Have you ever really stopped to think about how clicking send on an email in, say, New York makes it show up almost instantly and perfectly on a screen in Tokyo? Well, it's not magic, but it is a brilliant set of rules and some really clever hardware. Today, we're doing a quick-fire pop quiz on the absolute fundamentals that make our digital world tick. So let's just dive right in. It really all boils down to this one big question. How do these machines, whether they're just a few feet apart or on completely different continents, actually have a conversation that's coherent and reliable? We're going to get to the bottom of that by tackling a few core concepts, one question at a time. All right, first question. Let's talk about trust. You send a file, a photo, any kind of message. How do you know it arrived exactly as you sent it? Without a single bit getting messed up along the way? That's where this thing called the frame check sequence, or FCS, comes in. So what is it? Okay, so think of FCS as a digital proofreader for your data. It's this small, unique code that gets attached to every single chunk of data sent over a network. And its only job, really, is to be a quick mathematical check to make sure the data hasn't been scrambled by, electrical noise or any other kind of interference during its trip. So here's how that proofreading actually works. Let's say your computer sends the message, hello. Before it goes out, the computer runs a quick calculation on hello and gets a unique value. We call it a checksum. Let's say it's 10, 10, 10, 10. Now, when the receiver gets the message, it runs the exact same calculation. If it also gets 10, 10, 10, 10, boom, the data is perfect. If it gets anything else, it knows something went wrong and it just asks for a resend. It's that fast and that simple. Okay, so FCS makes sure our data is accurate. But how did two computers even agree to start a proper conversation? They can't just start firing data at each other, right? They need a formal introduction. And that brings us to our next question. What is the three-way handshake? The three-way handshake is basically the official opening ceremony for a reliable connection. It's the method used by TCP, that's the Transmission Control Protocol, a huge part of the internet, to make sure both sides are online, ready, and willing to communicate before even a single byte of your actual data gets sent. And it happens in three super simple steps. First, your computer, the client, sends a little packet called SYN. That basically means, hey, can we sync up and connect? The server on the other end replies with a SYN ACK, which says, yep, I got your request, and I'm also ready to sync. And finally, your computer sends back one last packet, ACK, which just confirms, awesome, I hear you're ready, let's do this. SYN, ACK, ACK. It's the perfect digital greeting. The easiest way to think about this is like a phone call. You don't just pick up the phone and start yelling information, do you? No, you say, hello, can you hear me? And you wait to hear, yes, I can hear you back. The three-way handshake is just the network version of that. It's all about making sure the line is open and both people are actually listening. And this isn't just about being polite, digitally speaking. This handshake is absolutely crucial. It gives you reliability, making sure the server is actually ready for your data. It synchronizes everything, so your data packets arrive in the right order. And really importantly, it helps prevent all sorts of annoying security issues, like a half-open connection where your computer thinks it's talking to a server that's already hung up. So we've got the rules for sending accurate data, and we have the etiquette for starting the conversation. But what about the actual physical roads that data travels on? Let's switch gears from the software rules to the hardware. And we'll start with the most basic piece of equipment you can find, the hub. So what is it? Right. A hub is, it's a central meeting point for devices on a network, but it's not very smart. The best way to think of it is like a simple power strip, but for data. When a piece of information comes into one of its ports, the hub doesn't know and it doesn't care where it's supposed to go. It just makes a copy and blasts it out to every single device plugged into it. This analogy is just perfect. Imagine you're at a round table and you want to tell your friend Alex a secret. If you're using a hub, you don't pass a quiet note. No, you stand up and you shout the secret to the entire table. Everybody hears it, but hopefully only Alex is actually listening. It might get the job done, but it's incredibly noisy, insecure, and super inefficient. Okay, so that round table is fine if everyone's sitting close together. But what happens when your network needs to stretch across a huge office or even a whole building? You see, over long distances, a digital signal gets tired and weak, kind of like a voice shouting from far away. So what's the solution? Well, it's a simple little device called a repeater. A repeater does exactly what its name says. It repeats and boosts the signal. It sits in the middle of a long cable, listens for that faint, weak signal coming in, cleans it up, regenerates it back to its original strength, and then sends it on its way, good as new. It's pretty much the network equivalent of a fresh cup of coffee for your data, just letting it go the extra mile. All right, so if the hub is the noisy, inefficient town crier of the networking world, what's the smarter, more modern way to do things? That brings us to the device that runs pretty much every local network today, the switch. So what is it, and what makes it so different? So a switch is the intelligent evolution of the hub. From the outside, it looks almost the same, just a box with a bunch of ports, but on the inside, it's a total genius. It actually learns the unique address of every single device plugged into it. So when data comes in, the switch just looks at the destination and sends that data only to the one port where the intended recipient is. This classroom analogy just nails the difference. A hub is like a teacher shouting a private grade out to the entire class. It's disruptive, and everyone hears it. A switch, on the other hand, is like that same teacher walking over to a student's desk and whispering the grade directly to them. It's private, it's targeted, and it doesn't interrupt anyone else. And that difference in efficiency, it's everything. Because a hub shouts, only one device on that network can talk at a time, otherwise it just becomes a chaotic traffic jam. But a switch creates these private, direct lines, so multiple conversations can happen all at once, at full speed. This is exactly why your home network doesn't grind to a halt when one person is gaming, another is on a video call, and someone else is streaming a movie. Now, once you realize you need that smart, efficient switch, you'll find they actually come in a few different flavors. Each one is built for a specific job, so let's quickly run through the main types you're likely to see out there. First up is the unmanaged switch. This is the one most of us have at home. It is the absolute definition of plug and play. You take it out of the box, you plug in your devices, and that's it. It just works. There's no software, no setup. It's perfect for connecting your computer, your gaming console, and your TV in a small network. Then you've got the managed switch. Now this is the professional-grade tool. It gives a network administrator total control to do things like prioritize certain traffic, say voice calls over file downloads, and set up really powerful security features. It's pretty much essential for running any large, stable, and secure business network. And finally, there's the incredibly convenient PoE, or Power over Ethernet switch. This clever device sends both your network data and electrical power over the very same Ethernet cable. This is a total game changer for installing things like security cameras, wireless access points, or office phones, because you don't need to run a separate power outlet to them. So if you remember just one thing about all this network hardware, make it this. A hub shouts at everyone, and that creates a slow, congested party line. A switch intelligently directs traffic, allowing for multiple private conversations at once. And that is the difference between a frustratingly slow network and a fast, efficient one. And there you have it. Our little crash course is done. We've covered how data stays accurate, how connections get started, and the hardware that directs all the traffic. But honestly, we've only just scratched the surface. What about the protocols like DNS and DHCP that really bring the network to life? Let us know what you want us to explain next. Thanks for tuning in.